from Government Model Engineering College, Cochin, and worked in organizations like Microsoft, Fractal, and currently associated with Software Healthcare Systems as a senior full stack engineer. She's a data science enthusiast, and what makes her unique is her ability to tell stories through data. This is again a very brief about Julian. I really thank her for accepting our invitation to present a workshop on EDA, which was requested by many participants. We are recording this session, so those who are not who could not make it up, we will anyway upload it in our WiDS Hyderabad YouTube channel. They can view it there. And like every time, we'll have question and answers towards the end. You can use the chat box to write your queries there, or you may raise your hand and we'll call out your name. Over to you, Julian.
Thank you, Sulakshana. Thank you for the invite. I'm trying to share my screen. Just to let me know when it's visible. Is it visible?
Yes.
Great. So, hi everybody. I am happy that all of you have taken out the time today to study data science. The agenda for today looks like this. We're going to have a few problem-solving techniques being shared, mainly focusing on binary classification, and then we'll go ahead and jump right into EDA, which will be having univariate and bivariate. So I'm assuming a lot of you have already gotten your hands dirty and understood what a life cycle looks like, but this is just a brief on what stages will be there even after the datathon is over. So as budding data scientists or as actually working data scientists, you do have to understand that currently in the datathon, the problem definition part has been solved for us because we have an objective that we're actually planning to, achieve. But in the real world, you might have to have conversations with your clients and understand the problem to as much as you can, because sometimes there'll be key problems, key problem statements, key points within the statement that will be missing, and you'll have to have those hard conversations with them. Provided that you have the definition stage done, the data selection part comes in. Again, in our case, since it's a datathon within Kaggle, you have a very authentic source of MIT being the data source. So you don't have to worry about whether it is a good source or not before you jump into the EDA, because you're going to spend 2 hours or more, or maybe you can skip this step as well. But what EDA helps you do is actually understand your data and what relationship your target variable will have with respect to the other variables. We'll get into detail once we do a case study for this in our session today. You'll understand what target variables are and what are the other variables. Then you can have some cleaning done, data wrangling done. You can transform your data into, sometimes you might not want to include all of the columns. You can drop missing values. We'll do some of that today as well. And once you've made those decisions, like as a data scientist, you're supposed to make decisions at each and every step on what do I want my data to look like, what is the kind of data I'm going to send into. You might have to do some pre-processing steps to reduce the time, to increase your efficiency, and then you move on to feature selection, model selection. And I'm sure the way WiDS Hyderabad is actually organizing this these workshops, you'll go through all of these stages. So provided all of that happens, you eventually end up doing this. So let's focus on these on EDA today. And just before we do that, let's also understand that. So I'm assuming you guys have some idea about this, but let's just also assume if there is somebody who has a doubt, your data set will have a lot of columns, okay? And these columns can be of two types. They might be variables that we call them, might be a continuous variable based on the fact that they might be numbers. They'll be continuous variables. It could be data moving from minus infinity to plus infinity, or it could be categorical variables where they are actually A, B, C, D, or they could be binary values 0 to 1, 0 or 1. They're ordinal values. So when I talk about ordinal values, I mean by, how you fill surveys saying strongly agree, strongly disagree, right? So that is categorical. Now, depending upon the decision that you have to make, what should I go ahead and apply in this might you can take the decision sometimes based on your input, sometimes based on your output. If it's by your input, you might look at your data and see whether it has been labeled or not. If it has been labeled, you are going to definitely go ahead and try doing a supervised learning. Now, so a supervised learning thing is basically when you know that there can be human intervention. Supposing you know how companies hire interns and help and get their data labeled for them. Cure AI does that. A lot of people who are involved in the data labeling process actually go through all of the data, like, okay, this X-ray has cancer, this X-ray does not have cancer. They label these things, and then we train our model by giving this set of data set that has been labeled, and then the more your data, the more kind of labeled data your model sees, the better it gets trained, because your test data might have is completely unknown, and you might have to make sure that your model is trained for all kind of scenarios. Now, if your input data is unlabeled, and your aim is basically to try to find some kind of pattern within that, and sometimes we will actually call this being the true AI. So when a computer is trying to learn on its own, there is no human being to intervene. We have very little information about this. So what we try to find patterns, we try to identify and learn, and there'll be different kinds of models that you can end up creating. It could be a deep learning model, it could be a neural network. With reinforcement, you could penalize your model for getting it right. You could reward it for getting it. You could penalize it for getting it wrong, and reward it for that. So there are different kinds of things you could do based on whether your data is unlabeled, and that's another and totally another class that should be taken later on maybe. So as I mentioned, if you try to find patterns and you try to create clusters out of this, and sometimes some data will not follow any pattern, and they'll be called the outliers. So they might not fall into any cluster. You might have one set of data that is actually within this blue circle, some would be in the red circle, but some would be in the yellow circle. These are three different kinds of clusters. One of the very common algorithms uses the k-means algorithm, where this algorithm is basically trying to divide. You have a large set of data and you're trying to divide it into k number of groups. But even then, there could be some things, these green circles that you see, they're all outliers. They don't fall into any certain category. And in k-means, what happens is you try to do it on a multiple rounds of clustering is done. And if you take an average out of them, and none of the points change their groups again, then you know that you have actually clustered them in the right way. So like I mentioned, the input part is that. Now, when you have a very good solid data information that your output of your model should be a number, like say I'm trying to predict the price of gold tomorrow. I will have a set of data points which will be like say for every year so far. I am trying to predict what is the data going to be. So if there was a line here that said this is the rate right now at 2021 January. This is so I'm supposed to predict it for something like this. Then I know it's a regression model. So regression models are basically used when you have prediction to be done. Now, sometimes you might have problems where you're trying to classify. And so it could be like, is the image of a cat or a dog, or is this patient having cancer or not having cancer, or is a person having type 1 diabetes or type 2 diabetes? That is when you have a classification problem. So again, both of this is going to be supervised because you have had a certain set of training data available for you, where you know what your output should be, and you're going to train your model to actually create outputs. Look at the test data, and then create these kind of classes or predict this kind of a value. And if it is a set of input numbers, it could be a clustering problem. Now, when I talk about regression, there are two kinds of regression, three maybe, if you include multiple. So basically, regression, on a very brief note, it is y is equal to mx. If you guys have taken a look at ISLR, which is one of the basic first books, must-read books that you should be reading, Introduction to Statistical Learning with R, or there are GitHub versions with Python also available. So one of the first examples you bring into is this picture. This is basically, you are trying to understand whether, as a company, you would want to put in more money into your advertising for TV or radio or newspaper. So this is basic marketing intelligence that every company will have in place. and they are trying to find out whether their sales have been influenced by their TV budget. You put in money into your TV budget, you need to see a sales, an influence on your sales for that. So maybe you might buy a new phone might be, or whatever you buy. It could be because of the ads that you see on the paper, or it could be because of the ads that you see on TV. So, or maybe Google ads. So you could have these kind of y is equal to mx, where x is your variable that is independent, but y is that sales that you're trying to find out, right? It's a dependent variable. It's dependent on x, and m is that slope that you can see here, right? So most of the cases, linear regression will work, but it could become problematic when there are redundant features. And if I try to increase the number of x here in the same equation, if I have more than one independent variables that is actually influencing y, I will call it a multiple regression or poly regression, linear regression model. It's the same funda here, but you just have more predictor variables. If you have two or more, then that's a multiple linear regression. Now you could, the next case of regression is logistic, but this is binary classification. Now, in this case, the y that you saw here can vary from minus infinity to plus infinity. It can go on. In case of logistic regression, you will have only two kinds of variables, and y has to be between 0 or 1. And that is one of the major differences. Please keep this in mind. In binary classification, this is one of the first things that will be suggested. Now, if you, so this is one of the most commonly asked doubts, why can't we continue using linear regression? It's because, like I mentioned, y will have a continuous set of variables, ranges, outputs in linear regression, but in case of logistic regression, you will be having either 0 or it'll be either 1. So that creates the two classes on which our output variable is going to be a categorical variable. It'll be either in 0 or it'll be in 1. And it makes use of a sigmoid function here to convert what was an infinity from minus infinity to plus infinity. It will actually cut off what was beyond 1 and it'll cut off what was below 0, and it'll make it lie within this range of 0 and 1, right? The second thing, second classification, binary classification algorithm used is SVMs, which is, again, we're trying to actually create this class, two classes will be trying to create. But in this case, let me show you the graph. It helps understand this better. In this case, the black dots are in one class, the white dots with black circles here is another class. So in SVM, we try to find that optimal hyperplane. It is a little more advanced in terms of, there are a lot of good, one MIT professor that teaches SVM really well. You should definitely go through it. I'll share the links after this talk, where your aim is actually to find that perfect hyperplane that actually divides and creates a distance between these two classes. And you're next time you see another test data example, you will try to map it to one of these spaces. It'll be either in the space of the black dots or it'll be in the space of the white dots. So you will again have the requirement of the fact that you need training data here first. That's SVM for you on a very brief note, but as I mentioned, do go ahead and read a lot more into SVM because it's a very, very interesting topic. The next very commonly used algorithm is decision trees. In this case, decision trees are very easily understandable because this is how humans actually think. You have a certain decision node, and the only complication in this is which feature to be put into. That attribute that you find out will have certain complications, and there are a lot of methods to find that right attribute to put into it. But once you have that attribute decided, it basically makes it really simple. The root node is your decision node, and the first decision node is called the root, and everything else is the child node. And based on each and every variable and how its attributes, you can make these decisions whether it goes into this branch or the other branch. This is the most simple one, and they call it the white box algorithm because it's very simple and transparent on what it's doing, compared to when you look at a neural network and you don't know which node is actually learning which part of the cat or in that image or the dog image, and you go into neural networks and CNNs, so on. I think I should have started with this Bayes algorithm the first, because this is one of the first things that you can do, because it's super fast. It's very simple. If you have a very large data set and you are asked by a manager to just quickly find out what is your class, this is again a classification algorithm where you can make use of Bayes algorithm directly, provided that you know the sum of the probability. Like you have data set, you can make a frequency data set out of that. Use this formula. It's a very simple formula. All of us have studied this in 12th standard during board exams. We actually had a lot of excitement when we saw, oh, it's a Bayes algorithm problem. So very basic, and it helps you quickly create classes. And here, the only naive assumption that this algorithm has is that every pair of feature is independent. You will have multiple features there. It can work for multi-class as well. But we have that assumption that every single feature is independent of the other, and you can go ahead and apply this Bayes algorithm. The final thing I would like to introduce you to is the binary classification algorithm called KNN, where KNN here is basically, if you see carefully here, we have two groups in this. We have the red dots and we have the green circles, squares. Now, our aim is to find, when you have a new data point, that is that blue star that you see there, that star, in which group should it lie? Okay, and the algorithm is very simple here. We try to find the distance, the Euclidean distance between that test data and every single row of training data that we have. We find out what is the smallest distance, and from that smallest distance, all of these small distances would be actually mapping to which class does it belong to. Is it the red circle class, or is it the green square class? And according to that, whichever is the majority one, here in this case, k is equal to 3, and it creates a circle with that test data being at the center. And that's why we are able to conclude that the star is actually within that first class. So that's a brief on what strategies you can use for finding out applying for binary classification problems. Once you have come to that decision that you have to apply binary classification, then go ahead and apply any of these. And it could be sometimes, if you're in the beginning stage, you might have to do a test and trial and error. But I hope this actually helps you understand what to apply when. We're moving to the next part of our topic, that is EDA. In EDA, basically, as I mentioned, we're trying to understand what is the relationship of our target variable in terms of the variables. So let's just go ahead and quickly. So in Taggle, I think I've tried sharing this. Can all of you just take out this notebook? Okay. I've shared it on the chat. Click on a copy and edit. You should be able to see a copy and edit here. So we can go ahead and do this together. And in Taggle, you should be able to look out for house prices. This is another competition. I'm not going to our WiDS Datathon competition because that's what we're going to be working on. I'm giving an example of another competition that's been there for quite some time, just to give you an idea. So, like, will be helping you understand what is the target variable here. In this case, we are trying our main the competition. Whenever you're in a competition, the problem statement is defined to you. We're trying to predict the sale prices. Okay, and in Kaggle, that actually very simple when it comes to the fact that they give us a the data set, they give us a definition of everything. So here we have defined that sale price is our target variable. And with EDA, what we're trying to find out is what is the relationship of this target variable with all of the other variables. Okay. So we're going to use either univariate or bivariate. And here I'm going to give you an example of all of them. Under univariate, we'll either try to plot a frequency distribution table, or frequency distribution plot, or a bar chart, or histograms, or pie charts. I know pie charts are not anyone's favorite, but we'll just cover that just for understanding that is also possible. And again, in terms of bivariate, whenever you have two continuous variables, please remember continuous variables are again numbers, and you don't need to worry about what they are because you can actually print them and see whether it's numbers or not. So here everything has been given as a definition, as in what is what. Like here it's a quality. So quality might have a certain, this could be a categorical variable, and you might have square feet given here. So if you look at it, you have let's just find, there's a total. So total basement square feet area, this is definitely going to be a number. So if you have two continuous variables, a scatter plot is perfect. If you have one categorical and one continuous variable, a box plot. I'll jump into what its definition and interpretation looks like. But if you have, again, if you have two categorical variables together, it's a mosaic plot. So that I can leave for your practice. But let's jump into what it looks like. So I'm hoping everybody has access to the Kaggle notebook. Please go ahead and click on copy and edit, and you can go ahead and do this along with me. It's a workshop, it should be hands-on. So let's see. What I'm doing here is you can ignore these things. We don't need to import all of this. We just need pandas, matplotlib, seaborn, and numpy. I'll explain as we go what we're using this for. And pandas is extremely powerful. I'm sure all of you know about this already. So what we're going to do is, if you have any confusion about this, I'll just mention it once. In order to get the file path, just click on copy file path here and put it here directly. Just paste it here, it comes over here. So house prices has our data completely taken. Just to see what it looks like, I've printed the head of this. So as you can see, you have some NaN values. Very on the first round, you can see that this is our sales price. This is what we're trying to predict, just like I mentioned, the gold prices that we could have predicted. So in this case, we know that what we're trying to do is we're going to see whether this is affected by these features. Does the pool area impact it? Does the year sold impact it? Does its condition while it's being sold impacted, or on which kind of a street is it? So these are the different columns that we have. There are 81 columns and around 1,460 rows of this. So this is how you can get the columns from this. By doing shape, I get the rows and columns. Here, in terms of describe what it does is, it's one of the basic things. You can just find out what is the mean and standard deviation for the entire data set altogether. These are just basic things. You can do info, describe, head, to just get a feel of what your data set looks like. So that's the first thing. Now that you have that in place, let's try to find out whether there's any relationship between like one of the first things I could see was the street in our columns. So let's see if there's a relationship between the sale price and the street. So what I've done is I've tried to create a basic univariate plot, which is bar plot. I've used matplotlib here. PLT is matplotlib that I had imported earlier. And I've just given what the y-axis label should be, the x-axis label should be. And here you go. We had only two variables and only two kinds of streets, as a paved street or a gravel street here. And based on that, it's very clear. It's with EDA, what is quick for us is in one glance we can understand that the sale price of a house that has a paved street or is in the locality of a paved street, it has a higher price, right? So that's one very quick conclusion that we can come into. And if we have to see just a histogram on what the sale prices looks like, this is directly a histogram. plt.hist gives you a histogram here. And you can see in terms of this here, I've not used any bins, but here you can still see like around 150 houses have a price range of less than maybe 1,50,000. This is all in USD, I think, because we saw basement and all. I don't think Indian houses have basements, but this is a range. If I were to put a bin number here, say 30, I could do 50, I could do 200. But based on that, you can actually see the scale here changing. The best number of bins, that question is actually very debatable, and you have a vast amount of literature to actually find out what is the best number of bins you can use for a particular scenario. And I've attached in this notebook itself this Stack Overflow question, which actually gives you a lot of good links as to what are the rule of thumbs that you have. You can go ahead and check out what are these rules. But for our case, it's just a very basic thing that we're trying to understand. Okay, there are different kinds of sale prices between 1 lakh to 2 lakh. There might be around these many number of houses that have that. So this is just a count that we have seen. You can use seahorse also to do this. I've just used matplotlib here. Here in this case now, let us try to also plot the next kind of univariate analysis that we have is for a pie chart. What I've done is basically I've gone to matplotlib's documentation. Always know every single library, be it Plotly. There's Plotly for panda or pandas or seahorse or matplotlib. All of this allows you to create data visualizations, and all of them have detailed documentations. If you have any doubt on what is the function and how do I create a certain plot, just simply Google that and it'll take you straight to the documentation. And you can just go ahead. So this is their first example that I could see for pie chart. And what I've done is I've tried to just plot it for our data set. In terms of our data set, what I could use was, I've not aggregated this here, but I've taken lot shape as one of the columns. And I've taken just the first 4 values of sale price. And I've tried to plot it together with this. The explode is one of the features that helps you explode one particular quadrant of this pie, right? It's just pure information, nothing. There's not a lot we can actually. I find pie charts confusing, so we'll move on to our distribution plots. Here I've used seahorse. I've imported that as a SNS. I don't have to write the whole thing, but inside this the distribution plot, it looks. So normally we would like this to be a perfect bell curve, right? Here in this case, it's clear that it's not the center, it's not symmetric. If you have any deviation, towards, if it's moved from the center to the right, to the left here, in this case, you know that there is some skewness, and if there's a tail around here, there is some kurtosis. And it's very easy to find how much that is by just doing a dot skew and a dot curt in terms of you're again focusing only on the column called sale price, and you can find how much that is there. Please do go ahead and read a lot more on this, because everything that I mentioned here has some maths to it. There'll be some math formula. If you are interested, please do go ahead and when you're free, I would highly encourage you to go ahead and read what is that max formula here. But like I mentioned, it's just that symmetry. If it's towards this thing, and if there's a tail, you know that this is not a normal distribution. Okay. Now, what else can we do with this? We can try to find relationships between the continuous variables. So that is what comes under bivariate. And the first thing that we mentioned was a scatter plot. So in this case, like I mentioned again, you can go to the house prices data part, and you can try to find out what GRL, Great Live Area. This was Gravel. There's a GR. Yeah, see, GR live area. So this is basically the ground living area square feet. That means above ground. Like I mentioned, these houses have basements. So what is below the ground is the basement, and what is above the ground is your that comes under this variable. So I've taken this one variable, and just for that variable and the sale price, Pandas allows you to just take out just those 2 variables, concatenate them together, and that is our data. And I've used that data to create a scatter plot. So I've just given x is equal to that the GRLV area, ground above ground living area, and the sale price. So this is what it looks like. Again, please note this is somewhat looking like a cone, right? It is starting from this part. It is looking towards like a cone. Remember that I mentioned this word cone because we're going to discuss what that is and why this might be a little problematic. But that put aside, you do see that there is, if I try to draw a straight line like you saw in y is equal to mx linear relationship, there is a linear regression. So if you have larger amount of above ground living area, definitely the sale price will increase. 1,000 square feet is 30 lakhs, and then maybe 2,000 will be 60 lakhs, right? So that's a linear relationship. And similarly, the total basement area that is in square feet. In this also there is we have tried to plot a scatter plot again against these 2. Here also there's a linear regression, but there's a slight bend towards it. It's like a parabola. It's like somewhat exponential. Okay. We don't know why that's happening, but it's somewhat exponential. So these are the conclusions I want you all to have when you try to go ahead and do the datathon and you want to find out what is the relation between every variable here and there. Now, the next thing is when you have one continuous and one categorical, you can go ahead and try to plot a heat map or we'll come to heat map later. But first, let's just discuss on what a box and whiskers plot is. Why? Because even besides outside the Datathon, this is going to be helpful to you. One of the Reiki clients that I had worked with had this as a requirement in one of their charts that we had made. So sometimes this can be a little confusing, but let's try to break it down. A box and whiskers plot basically has here what I've tried to see, like this is from one of the YouTube videos. I can share the link of this somewhere in the notebook here itself. If there are these points as your game points, say Kobe Bryant, okay, great player, miss him. So it's one of our great losses. So what we have done here is you try to say plot his scores here, and from the scores we tried to find out what is the least and what is the maximum. So the least was 5, the maximum was 32, okay, and the median, his median score points, game points were 17. So 17 is this blue line here. After you have figured out that, 10 and 20 are the medians within this range. From between 5 and 17, 10 was the median, and between 17 and 32, 20 was the median. So we have plotted that here. Using here in terms of box and mixers, what we try to do is we call that 10, the inner median for the first thing, the upper quartile. That is, if you say this is the median, what is above this, like what is lower than this, is your upper quartile range, and this is a lower quartile range. So inside the lower quartile, this is the point where the lower quartile is. Where the moment you have this upper quartile and the lower quartile, you can create this box. This box is always going to lie between the upper quartile and the lower quartile. And these points are actually, so you can actually figure out how this is going to, the interquartile is, so basically you can see 4 areas. This is area number 1, this is area number 2, 3 and 4. So this is 25% of your data that lies within this. It is always in terms of 25%. So this plus this is going to be 50%. This is your 25%. So if you have a certain average coming out here as this, if I were to take just these 3 parts, it will be 75%. It is always in terms of quartiles that we talk in a box and mixers plot. Upper quartile would be 75% of the scores would fall below the upper quartile. So I have mentioned these definitions. Do go ahead and read these and let me know if you have any doubts. I've also shared links to one very good resource. Any stats and math doubts that you have, please do visit those particular concepts within Khan Academy. Even this box plot has been described really easily here. I'll just quickly take you to one of those examples. For example, interpretation. So go to the interpretation straight off here. What is the percentage of boxes of raisins weighed more than 29 grams? Again, here your quartile range is 29. 25% of the data is below 29. So where is 29 here? This is where your 29 is. So you know that only this much is Q1 is being defined as 29 and 75% is above 29. Always talk in terms of quartile. I hope I've cleared this. Here we are gonna, in terms of our house prices, we have a categorical variable called the overall quality, that is the overall quality of the house. And here we have tried to plot a box plot, again using seahorse. So again, see, the documentation will have all of this, what to give in X, what to give in Y. Very simple. I've given the data again here as a concatenation of the sale price and my variable. What is my variable? The overall quality. This is a categorical variable. I cannot do anything else with this. So I've plotted a box plot here, and it's a very easy to understand graph in terms of this, because you know that as your overall quality of your house increases, the sale price would have a larger range of value, right? It's more costly when it's in a good condition. Similarly, I've done it for year built, and in year built, again, you can see that this is for the newer houses. You will have to spend a lot more in terms of the older houses. This is from 1872 till 2010. So this is a very easy to read graph again. And you can try to derive these conclusions from these graphs, where the relationship is strong in terms of, in case of the overall quality, basically when we saw that, we know that the sale price will increase with the overall quality. Now, the scatter plot that we saw earlier was with great live area and the basement area. Again, you had a linear relationship with them. So these are just 4 variables: the year built, the overall quality, the above ground and below ground. But we know that there were so many more variables, right? And it might look really overwhelming initially. But what you can quickly do, some practical strategies I would like to share is make a heat map. Okay, when you do a heat map, what you see is basically what is the correlation between every variable with every other variable. Now, if this also looks confusing to you, because I know there might be some people who are colorblind, and even there, if they're not colorblind, it might be really difficult to understand what is this gradient of color. Is it similar to this? You might feel that there is some similarity between this happening, but how do you actually come to that conclusion? So I've plotted. So before I jump into that, I'm just going to show you what I had used to create this heat map. You created a correlation matrix. And a correlation matrix, if you have a data frame in pandas, all you have to do is do a dot cor. And this correlation matrix, if you just print it out, you can see the same heat map in the numerical form. So you see ID and ID, you see this diagonal of this matrix has 1, 1, 1. This is the 1, 1, 1 that you see as white columns here, white boxes here. Okay. And similarly, you can go ahead and see what all these numbers are. With these numbers also, there is a lot of data. It's hard to process that. So what we're going to do is we're going to zoom that data. But I'll just pause here a little, and in case somebody here has no idea about what correlation is, we are just basically trying to find out if there's a linear relationship. You remember the y is equal to mx, right? So if your correlation comes out to be 1, it's a perfect positive correlation. If it's -1, it's perfect negative correlation. And the value can only lie between this 1 and -1. And as you see, there's a positive value till 0. There's a positive value, there's a positive correlation. If it is 0, there is no correlation. that can also be there in terms of this. In somewhere between this, if you see a 0, there is no correlation between those two variables at all. And then if it's a negative value, you can see there are a lot of negative values here. That means as one increases, the other decreases. That's what a negative correlation means. And the cliche example here is, do not ever go into this trap where you feel that correlation is causation. Never believe that, because if you see the sales of ice cream in summer goes high, and sunglasses also is high, that does not mean that if people are wearing sunglasses, they will also go and buy ice cream. There is no correlation between that, though they all have, both of them look like they have a positive relationship, right? So in terms of our heat map, like I mentioned, we were being overwhelmed with a lot of these things. But from the first look of this, like I mentioned, there were like some colors that had similarity, right? So if you can see this and this they're almost in the same trend as being followed. So it could be possible that you have this case of multicollinearity. That is, if you have 2 or more variables in this model that are completely linearly related with a perfect correlation, there could be this possibility. So that's why we're going to zoom in and find out which are the some variables that we can focus on. Even that entire heat map might be too many data, too many variables. What I've done is I've just taken the largest values of those, and that comes out to be, I've taken the top 10. And so that has reduced our number of variables to focus on currently. And like I mentioned, I'll be using NumPy here. What I've done that is basically to find out the correlation coefficient value. And that value is then being used to create the next heat map, zoomed in heat map, if I may say so. Here again, it becomes a little easier to focus on. It's a very small thing. There are just 10 of them. If you see these numbers closely, you see that there's a common trend here. You have these values are actually same, and that happens for 2 of these, actually several of these. So if I were to call them, I can say that there is no point in me looking at garage cars and garage area, because if you think sensibly, use some common sense, use your data intuition when you're doing this. If I have a bigger garage area, that means I can have more number of cars. So there is no need of me going and looking at garage cars again. I can use either one of those variables. So find out what are your twins between that. And like I mentioned, see, total basement and first floor seem to be twins because they have 0.61, 0.61, 0.54. This is the same trend that's happening. So they look like twins. So whatever looks like twins, remove one of them, focus on one. Okay. That is, again, I'm trying to make you create model that is parsimonious. You have less, be economical, focus on smaller number of variables so you can come to a better conclusion faster. In order to get a quicker look at the entire thing, SNS, that is Seahorse, basically provides you a very wonderful function that's called pair plot, and does in that one line will print this all of these charts. This whole thing comes into your dashboard the moment you do that one line, and hats off to whoever made this. So basically, it's a bunch of histograms and scatter plots. So in this again, you can zoom into and see what is the trend here, right? You can see that great live area with total BS7CF here has a conical structure. But it has a linear relationship. It is increasing, and similarly, there's a lot of linear relationship that you can see. This will give you an overall picture very quickly, right? So what is following a linear trend, what is not following a linear trend, what is having an exponential function trend, that can also be noticed, so on. So go ahead and try out inside this notebook itself. I have also included world happiness data for 2015 to 2019. Do the same things, describe, info, and then find out, plot all of these histograms and see what is the difference between this. And go ahead, and it's a data set that has the happiness score for all the countries. Finland is somewhere in the highest. Denmark is also highest. Very good prime ministers, very good rules. India is somewhere in the bottom with a score of 3 or 4. And you can try to find out what are their variables that actually contribute and influence those that happiness score. It could be the life expectancy and so on. I've tried to here also introduce you to a reg plot, the regression plot, the linear regression plot. You can see a certain relationship between this, but there could be sometimes your data might not actually look. So here in this, I tried to plot it against social support, and here I tried to plot life expectancy versus against the freedom to make life choices. So sometimes, like I mentioned, it might be really hard to find out whether your linear regression it might not be easy to actually find out whether there is a relationship or there is a correlation or not. I was just trying to use you also to XKCD. If you don't know what this, their cartoons really help you get the crux of the matter really quickly. Moving back to the house prices. In house prices also, what you can go ahead and check out is missing values. In terms of those missing values, like I wanted to just introduce you to homoscedasticity, because we saw that cone-like structure, right? In happiness, there was no missing values. Like you can plot it by just doing is null dot sum. If you see nothing, there is nothing missing, that's great. But if you do it for house prices, is null dot sum, you can see there's a lot of missing values. I've plotted just a percentage by doing this, dividing this by percent and then seeing what percentage of missing values is there. You remember we saw a lot of NaN, we saw a lot of zeros in the initial stage. One of the best things we do is just drop what is highly missing. There's a lot of missing data, just drop them and reduce your data set itself. And once you've done that, again, check whether you have actually dropped everything. Check it should be 0. And you remember we had 81 columns. After dropping all of the missing values, I just have 63 columns to focus on. And the assumption that you can look for is, like I mentioned, you want your distribution plot to look normal, right? It should be a perfect bell-like structure. If it has that skewness and kurtosis, you know that you want to make some changes there. And once your normality is actually taken care of, you can get rid of problems like heteroscedasticity. Now, what I mean by homoscedasticity and heteroscedasticity is, it's a very simple thing. Like the moment you see a cone-like structure in your scatter plot, know that there is heteroscedasticity that has come into the picture. I've added a link to Geeks for Geeks, but I don't see it here. But if you can just basically look for what that definition looks like. I won't waste time doing it here, but the assumption is that you remember seeing this linear regression, right? In this linear regression, whatever is away from this line has an error. And our assumption is that all of these errors also have a constant variance. That is called homoscedasticity. The moment you violate that assumption, you have a heteroscedasticity model. We don't want that. And in terms of this, these house prices, I have been able to, we want to get rid of that, right? So let's see this in outliers. I can discuss outliers later, but let's just see this. So say if you make use of the distribution plot here and plot sale price, we did see this problem, right? And we know that this is how it should have been. And there's this beautiful thing called prop plot, which actually creates a probability plot against this line, and it is not in the line exactly. Why is that? Is because of heteroscedasticity. So what I've done is done a transformation, a very basic transformation. It's a log transformation. I've used NumPy here, and I do it on sale price itself. And when I use the same thing, I'm plotting the distribution plot and the probability plot. Once the transformation is done, voila, see, it all correctly falls on this. The same thing can be done for the things that we actually saw the problem. We saw the problem for Great Live area. It was a conical structure, right? Here, again, this is the actual plot. There is a lot of deviation here. If I do the same log transformation here on Great Live area, you can see that, and I plot the same thing again it gets fixed, right? So go ahead and find out what, please read in detail. I'm rushing a little. Whenever you are trying to do this, in the first attempt, if you see this, let me show you how it looks like now. Between Great Live area and sale price, that conical structure is gone. It has become very homogeneous here. So we want this, whenever we are plotting a scatter plot, we want that homogeneity to be there. So that takes care of our problem. Like the moment it makes it a normal thing, if normality is taken care of, that is also taken care of. So these are the things, conclusion, that you can definitely go and find out through your EDA. I've also included the World Bank data where you can practice all of this all over again. I have 5 minutes for Q&A. Please let me know if I confused you, or if there's anything that is confusing.
Julian, that's a lot of information actually. And do we have any questions? We were expecting around 50, Julian, because the request was coming up for an EDA workshop from most of the, but considering the fact that today is a holiday and most of them checked with their teammates on whether the recording would be available. And thankfully, we are recording this session, and we would definitely share it with them. It will be uploaded in the YouTube channel also.
Sure.
And we have, any queries, anybody?
So the thing is,
you can move on, Julian. Probably you can, yeah.
Go ahead and I would like you all to practice. There are a lot of competitions in Kaggle, and they're not very hard. So don't feel intimidated by the fact that you are new to this or anything. Practice these things, and they're very simple. And if you see a competition here, you can also make use of this. Like I wanted to just show you that when you click on a particular training data, whatever data you're clicking or you're looking at, Kaggle also provides you EDA within this itself. So you can actually find a lot of data within this. Go ahead and always make sure you look at these things before you start this thing. A lot of EDA done by Kaggle itself. And if I was to click on this directly here, Kaggle also lets me see the entire data set here. So that is one thing I want to.
We'll take one query. Sorry to interrupt.
Sure.
We'll take one query. Yeah. Please go on, sir. Chandrasekhar, sir, please go on.
Please confirm.
Sir, your voice is breaking.
Yeah, please confirm if you can hear me.
Yes. Yeah. Go on.
Yes, thank you. I'm Chandrasekhar from WiDS Hyderabad. Good evening, Julian. This was a very informative session. My query is very, basic thing. This is the first time most of us are, attending a Kaggle hackathon. So the question is, there would be some subtle differences between how people perform the EDA, and that could actually give the accuracies differently for each one, right? So when we are submitting the output, what would be the criteria to judge which is correct, because it looks quite subjective in nature. Like someone may get 94% accuracy, someone may get 95% accuracy. So which is the better one, and it's very subjective, isn't it?
No, so it's so basically, first of all, if you're doing this for the first time, don't worry about whether your name is coming on the leaderboard or not. Go ahead and do your best, and your accuracy is definitely something that you can improve on. There are a lot of ways you can actually better your model in terms of the accuracy, and once your model is tested against the testing data that they have, they don't give you all of the data actually for testing, just 70% of that, but you are not aware about what 70% are they taking. So you can't actually see whether how WiDS is going to actually evaluate that. But what I would encourage you to do is not to focus on what their testing data is going to be, and simply to focus on your model and making that the best possible. And go ahead and do validation strategies like, whatever training data you have. Ideally, you don't need to do this, but what you can practice is doing this is divide your training data itself into train and test and hold out. There are validation strategies like K-fold and LOO. I'll share the links of that if you need. With these validation strategies, you can make sure that there is no data leakage happening, and you are able to manage different kinds of scenarios for unseen data, that is the testing data. If you want, I can share what all these validation strategies can be. There are a lot of practical approaches to doing this that you can implement and improve your model. Data improving your model also includes hyperparameter tuning, which itself is on its own. We need another class itself, but I can share links with Sulekha. She can share it with you. These things will definitely improve your accuracy. And as a beginner, if you're doing this for the first time, just don't bother about these things. ED is not the point where we actually think about the accuracy of the model. ED is just the beginning stage where you're understanding what your dataset looks like. And when you're done with the model selection, the feature engineering, you've created the model, that is when you actually find out, you validate whether your model is actually having the best accuracy it can. And you try to keep improving based on the tuning of your hyperparameters. Does that answer your question?
Yeah, thank you. Yeah, thank you.
I see another question on efficient methods.
Yeah.
So yeah, outliers we do. So I did have a code block for outliers. In terms of this, as in, so see, outlier detection itself is a very crucial thing, because every dataset will have that. There are companies like EugeneAI.ai is a company that actually does that itself, and anomalies can be on all levels. Now, in terms of this house prices notebook, if you have taken a copy of this, what you can see is in all of these scatter plots also there were outliers. Like you can see this point here in this plot is an outlier, and I can actually find out that exact point by looking at the data and remove that data. Just dropping the data will remove that, and when I try to plot it again, that is gone. Other ways that you can look for, like how I said, clustering. If you do that clustering part, am I not sharing my screen? Sorry.
No, Julian, we can't see your screen.
Sorry. So for what I was trying to show you here was there is this outlier part where you can clearly see in terms of this. This is the entire group, and this is not following any of these patterns. So what I've done is I've found out what exact point it is at, and I've dropped that. When I drop that and I plot this again, that part is gone. But there are still more that I can remove from this. It is depending on how satisfied you are with this completely right now. But there are other ways to do this, like how I mentioned, when you do a clustering, KNN, here also there are ways and you can visually see that there are some outliers. Besides this, I can let me get back and share if there are any known algorithms for this, because I do know that there is this company called Eugenia that does this for a living. They do warn you about whatever anomalies are there. There are a lot of methods on this, but I can't recall them right now. Let me get back to you on that if there are. Besides visual interpretation,
There's one more in the chat.
dimension reduction technique will be helpful to get better accuracy. Yeah, of course, do PCAs on your model. And so what we were trying to do is via EDA itself, we were trying to find out how we can reduce the number of variables to focus on. We can definitely go ahead and do a dimension reduction process entirely to also reduce the number of things that you have to send into your model and then find out what is the best objective, like basically find out what is your target variable most dependent upon. Definitely that can help you. We have only 30 features out of 180 features after doing EDA feature engineering. Fortunately, is performing. Can we pick a less number of features, or is it a bad strategy? So after doing EDA, so basically feature, what we were trying to do is focus on things like removing outliers, removing missing values. So there are cases when you don't even do EDA and you just look at maybe somebody else's notebook and see their EDA and then go ahead and do your feature selection, feature engineering. Dropping a certain thing because it does not have any values it is perfectly, it makes a sense. Like there are a lot of missing values, you can't actually make any sense out of that, or there is no correlation out of that. From the correlation part, you can maybe understand that and reduce your time. So what happens is these models themselves, when you choose, be it if you're choosing elastic net or if you're choosing within logistic regression itself, there'll be lasso, there'll be different named algorithms that you'll use, and they themselves will have feature selection happening. What happens is with EDA, with correlation and ANOVA that you try to do, you can reduce the number of features that you send within this model itself. It might not be a bad strategy, but what I've seen in real world applications is that usually when you want to reduce the number of time, the amount of time that your model takes, you do this pre-processing and remove it initially, and then send that the reduced universe of features into your model for further classification using lasso or ridge or whatever is your model that you've chosen. That can be done, but there is no harm in sending the entire thing and allowing the model itself to do the feature selection and then go ahead and find out the correct one. It also depends upon your objective. If your client says, no, I want all of these features to be used, you might have to use all of them as well. Have I answered the question?
Right. The questions that are coming up, Julian, are from, we have 4 to 5 institutions where we have the participants of Datathon. Okay, so the questions are coming from the faculty of these colleges.
Oh, okay.
Yeah, students have missed the workshop and they made their faculty attend. Yeah, that's all. We can move on.
Sure. So Sulekha, has everybody gotten access to
Julian,
the?
this is Sulakshna. Yeah.
Yeah. Do you have the access to my notebook? I have given most of the. I've covered the topics that I had for today.
Yes.
But please do ask.
You shared it in the chat box. The one that you shared in the chat box, I'm able to access.
I'll share the PPT as well. I can email that to you.
Sure, yeah, that would be of great help because that would be of great help. And all right, Julian.
Any other questions? Otherwise, we can wrap up.
Yeah, I think I don't see any questions in the chat box. So we'll end the call, Julian. Thanks for making it on a holiday and seriously, because because we were planning a couple of workshops from 29th onwards. The workshops, those are planned from 29th, would be more like education on AI, ML, data science and tools. So, not specifically for the competition thing. So we didn't wanted to delay this workshop. We had requests from around 50 students for this particular workshop, but less participation, but never mind, we have the recording, we'll share it with everybody. And
Sure.
thanks Tripti from Novartis for sharing the virtual platform to host our workshop today. And thank you everyone for joining on a holiday. Thank you, Julian. We'll be in touch.
Thank you. Thank you. Have fun
Yeah.
exploring. Bye.
Thank you so much. Have a good day. Bye-bye.